Let's look at polarity today. We start with the first example, beryllium chloride. First step, we draw the Lewis structure. This is the Lewis structure of beryllium chloride. The second step, we have to find the class of molecule. So on the central atom, there are 2 BP and 0 LP. Which shows the electron pair arrangement. The class of molecule will be AB2. A is for central atom, B is for terminal atom. And therefore, 2 BP and 0 LP shows molecular shape of linear. So we get the class of molecule AB2, we get the molecular shape as linear or molecular geometry as linear. Next, we are going to new term called bond dipole. Bond dipole existing due to the difference in electronegativity between two different elements. So it is because of electronegativity between two different elements. In this case, we have chlorine and beryllium. Between chlorine and beryllium, chlorine is more electronegative than beryllium. Therefore, chlorine forms what we call as a negative pole, kutub negative, while beryllium forms the positive pole, kutub positive. So how we use the symbol? This is positive pole and this is negative pole. That is the symbol we use. So going back to the diagram, we have to put the symbol. So we draw the Lewis structure again. Remember, the shape is linear. Okay, and then this is the negative pole, this is the positive pole, and this is the negative pole because chlorine is more electronegative. Therefore, I have to draw the bond dipole. Look is bond dipole. So positive like this, positive like this. Sorry. Okay, this is called bond dipole. Bond dipole have direction and magnitude. If you check this bond dipole, one is moving to the right, one is moving to the left. So they are moving in opposite direction. And the next question we should ask, resultant bond dipoles. What happened to them? Resultant bond dipoles. Resultant bond dipoles, the question is whether they can or they cannot cancel each other. That is the question. Okay, the resultant bond dipoles, can they cancel each other or cannot cancel each other? In the case of beryllium chloride, as students can see, one is moving to the right, one is moving to the left. They are moving in opposite direction and they can be cancelled each other because moving in opposite direction. So our answer will be resultant bond dipoles can cancel each other. That is the next point. The following point, we have to mention about dipole moment, which is, we use the symbol mu. So when the bond dipole can cancel each other, our conclusion, mu equals to 0. The dipole moment equals 0. Then our final conclusion will be, therefore, the molecule, which is BeCl2, is non-polar. Why they are non-polar? Because the bond dipole can be cancelled each other. The resultant bond dipoles can cancel each other. Therefore, the dipole moment is equals to 0. So BeCl2 is a nonpolar.